Yesterday we learned about proportions and ratios. Proportions are when you have ratios that are set equal. Today we're going to look and see how that relates to polygons. This is section 7.2, similar polygons. I'd like you to take notes on this video. Two polygons are called similar if all the angles are congruent and all the sides are proportional. Let me show you what I mean by that. Here's an example of two polygons that are similar. This little symbol right here means similar. So you're used to seeing a congruent symbol when that means equal measures. This symbol right here means similar. And this is a similarity statement. So it tells me that polygon ABCD is similar to polygon HGFE, and the order matters. And you can see that I have angles marked congruent here, angle A and angle H, and you can notice that they are in the first location in the name. Angle B is congruent to angle G, they're marked that way. Angle C is congruent to angle F, and angle D is congruent to angle E. It tells me which angles are similar, and it also tells me which sides are proportional or in the same ratio. So I can see that AB is in the same ratio to HG, so AB to HG, as BC is to GF. And CD is to FE. And then finally AD to HE. So the proportionality statement tells me everything I need to know about the polygon. This is what matters. Much in the picture, however the picture looks, this is what tells me what really is congruent and which sides are in the same ratio. The order matters. All congruent angles must line up. All proportional sides must also line up. Here are two polygons. I'm telling you that they are similar. ABCDE and JKLMN are similar. I want you to take a minute and I want you to match the angles that are congruent from this polygon to this polygon. Pause your video when you're ready for the answer. Press play again. And here they are. Again, it's the order. Angle A is congruent to angle J, B is congruent to K, C is congruent to L, D is congruent to M, E is congruent to N. That is what matters more than what the picture looks like. The picture can be deceiving. Now, in this next picture, I'd like to know whether or not the triangles are similar. Remember, the corresponding angles need to be congruent and the sides need to be proportional. Take a minute and decide. If you decide that they are similar, I want you to write a similarity statement where you match it, where you write the vertices in the proper order. Press pause on your video. When you're ready for the answer, press play again. Yes, they are similar, and you can see, first of all, the angles are all congruent. But as I check to see if the sides are proportional, I have to look at triangle XYZ and decide if it's proportional to triangle RPQ. Now, from XYZ, I locate the smallest side. That side is 6. I look at my other triangle and I locate the smallest side. I need to compare the smallest side to the smallest side. So I would compare 6 to 4, and I would check to see if that's the same as my medium side to my medium side. Here's the first medium side, here's the second medium side. So then I'll check to see if that's equal to 9/6, and then I would compare large to large. And then I would simplify my fractions. This is 3/2. This is 3/2. This is 3/2. So the sides are proportional. The angles are congruent. I would write a similarity statement. Triangle X, Y, Z is similar to triangle R, P, Q. Notice that the order matters. X is congruent to R, Y is congruent to P, Z is congruent to Q. If two polygons are similar, then the ratio of the lengths of the two corresponding sides is called the scale factor. So if I went through and I labeled these triangles with vertices, make this one ABC, and this one X, Y, Z, and I told you that triangle ABC is similar to triangle XYZ, the scale factor from triangle XYZ to triangle ABC is XZ over AC. This is the scale factor. And the order matters. Notice I'm comparing triangle XYZ to triangle ABC, and I could have used any of the sides that are corresponding. So the scale factor is also XY over AB, and it's also YZ over BC. And if the triangles truly are similar, all of these ratios will be the same ratio. And again, that's called the scale factor. Next, I want you to take a look. I have a rectangular patio around a pool, and it's similar to the pool as shown. I want you to calculate the scale factor of the patio to the pool, remembering that the order matters, and I would like you to find the ratio of the perimeters. Remember that these are both rectangles, so opposite sides are congruent, and I have all right angles. So, ready? I want you to find the scale factor, and I want you to find the ratio of their perimeters. Press pause, and when you're ready for the answer, press play again. Here's the answer. You can see that my scale factor is 24 over 16. That's the patio to the pool. Remember that the order matters. And I also could have looked at the ratio of the other two sides, the patio to the pool, 48 to 32. Both of these simplify to 1.5 or 3/2. Now, the perimeter of the patio, remembering the distance all the way around is the perimeter. The perimeter of the patio, and here's the perimeter of the pool. If I find the ratio, it's 144 over 96, which reduces to 1.5 or 3/2. What do you notice? Gee, I wonder. Take a look. 1.5, 1.5. The scale factor of the sides is the same ratio as the ratio of the perimeters. They're exactly the same. Now, here's a theorem. It says if two polygons are similar, then the ratio of their perimeters is equal to the ratios of the scale factors. In other words, the ratio of their corresponding sides. So here is something that, an example, I have polygon KLMN. It's similar to polygon PQRS. Then I know if I compare my perimeters that it has to be in the same ratio as all of the side lengths. So if I compare KL to PQ and I compare LM to QR and MN to RS and NK to SP, these ratios of corresponding sides are all equal to this ratio of the perimeters. Now, similarity is also helpful when I know that polygons are similar and I want to find a missing side length. the first step of the process is to decide which sides are corresponding. So if I look, I have a length for KL, and I notice that KL has to compare to QP. So KL has to compare to QP. I also notice that I have a side length for LM. Well, LM has to compare with PS. So what I can do is I can set up a proportion and solve. So 10 compares to 6 as 15 compares to Z. Now, yesterday we learned how to solve a proportion. So in order to solve, we cross multiply. So I get 10Z equals 15 times 6. And 15 times 6 is 90. Dividing both sides by 10, I find that Z has to be 9. So this side length here is 9. I have your homework posted on Schoology. Pay no attention to whatever that just said. I probably have changed the assignment. So check on Schoology for your homework and have a nice night. Now,